Okay, so here we shall explain the concept of the integrals of some particular functions and their applications. So we know that the integral of dx by x square minus a square, that is equals to 1 by 2a log of mod x minus a by x plus a plus c, and the integral dx by a square minus x square, that is given as 1 by 2a log mod of a plus x by a minus x plus c, and then integral dx by x square plus a square, that is equal to 1 by a tan inverse x by a plus c, and integral of dx by square root of x square minus a square, that is equal to log of mod x plus square root of x square minus a square plus c. Then the integral dx by square root of a square minus x square, that is equal to sine inverse x by a plus c. Then integral dx by square root of x square plus a square, that is equals to log of mod x plus square root of x square plus a square plus c. So uh, so instead of this x square minus a square or x square plus a square, we can have some quadratic function also. Means suppose we need to find the integral. Suppose we need to find the integral of the type dx by ax square plus bx plus c, means one quadratic function. If we have, then we should write this ax square plus bx plus c by completing the square. We have to first complete the square, so we can write it as a into x square by a, sorry, so if you take a as common from this, then we will get x square plus b by a x plus c by a, and then this can be written as a into x square plus b 2 into b by 2a into x plus b square by 4a square, then plus c by a minus b square by 4a square. So then this can be written as a into x minus means x plus b by 2a whole square, then plus c by a minus b square by 4a square. So here this integral can be written as then dx by a into x plus b by 2a whole square plus c by a minus b square by 4a square. Then so then if we put x plus b by 2a equals to t, then we will get dx will be equal to dt then. So then and and c by a minus b square by 4a square, we can write it as some plus or minus k square. It means that this can be written as, actually, if we take the LCM 4a square, then this will be 4ac minus b square. It is equal to, so now if 4ac minus b square is greater than 0, then we can write it as then this 4ac minus b square by 4a square can be written as some k square. And if this 4ac minus b square is negative, means it is less than 0, then we can write this 4ac minus b square by 4a square as minus k square. Okay, so then if, so here we can take case 1. Case 1 is that if 4ac minus b square is greater than 0, so then this integral I, let's say this is the integral I, then the integral I can be written as d, means dx equal to dt, so it will be dt by a into t square plus k square. So then this will be written as 1 by a into 1 by k, then tan inverse t by k plus c. Then we can substitute the values of k and a, means k and t. Then that will be the answer actually. And then so case 2, we can see that if suppose this 4ac minus b square is equal to 0, suppose, then this one can be written as then the integral I can be written as simply dt by a into t square, simply that. So then this can be written as 1 by a t power minus 2 plus 1 by minus 2 plus 1 plus c. So this will be minus 1 by a t plus c. And then the value of t we can substitute, which is x plus b by 2a. And then case 3 is that if 4ac minus b square is less than 0, then the integral I can be written as integral dt by a into t square minus k square. Since y, then this one we can take it as minus k, means 4ac minus b square by 4a square can be taken as minus k square. So then it will be equal to 1 by a tan inverse. No, sorry, it is not tan inverse. Something is wrong here. Yeah. So it will come 1 by a log, and 1 by 2a also will come. So it will be 1 by 2k also. 1 by 2k a into log of mod t minus k by t plus k plus c. And then we can substitute the values of t and k. So then this will be the answer in that case. And then similarly, if we have the integral I1, say, suppose it is of the type dx by square root of ax square plus bx plus c. So here also we can get case 1, case 2, and case 3. So case 1 is that if that means this can be written as actually integral dx by root a, 1 by root a, I can take it as common, and then this will be square root of x plus b by 2a whole square, then plus c by a minus b square by 4a square. Like this we can write. And then this can be written as 1 by root a integral dx by square root of t square plus minus k square. So case 1 is that if this 4ac means this will be and this I can write it as means c by a minus b square by 4a square, that is suppose greater than 0. Then we can take it as c by a minus b square by 4a square, we can take it as some k square. So then the integral I1, then the value of the integral I1 will be equal to 1 by root a integral dx by t square root of t square plus k square. So then the answer will be 1 by root a and log of mod t plus square root of t square plus k square plus c. And then the values of t and k we can substitute here. And then the case 2 is that if this one c by a minus b square by 4a square is equal to 0, then simply the integral I1 we can write it as 1 by root a integral, sorry, this will be dt. Here also this will be dt. Yeah, this will be dt. Okay. So then, so this will be one, sorry, this will be dt here. This will be also dt, sorry. Yeah, so then the integral one, so it will be, since here also we can, here, sorry, this will be dx. Something mistake. When x, when the expression for x has been used, then we should use dx. And when the expression for t has been used, then we should write dt. Since why here we are substituting x plus b by 2 as t, then we are getting dx equal to dt actually. Okay. Okay. So then the integral I1 will be 1 by root a into, this will be dt by root over t square. So this will be t only. So 1 by a integral dt by t. So that will be equal to 1 by root a log mod t plus c. And then, so this is case 2. And then case 3. Case 3 will be if this c by a minus b square by 4a square is less than 0. Then we can take this c by a minus b square by 4a square as some minus of k square. So then the integral I1 can be written as 1 by root a integral dt by square root of t square minus k square. And then that will be equal to 1 by root a. So 1 by root a, this will be equal to mm, integral. Okay, so 1 by root a log mod t plus square root of t square minus k square plus c. So this will be the answer. And then suppose if the integral I2 is of the type integral dx by square root of, suppose it is written, suppose it is, this a is negative, suppose, means it is minus ax square plus bx plus c, like this. Then that can be written in the form, it's like dt by and root a, I can take it as common some. Then we can write it in the form, suppose t square sorry, we can write it as some k square minus t square. In this form we can write. Then this integral will be 1 by root a, 1 by root a into sine inverse t by k plus c. And then we can put the values of k and t. And then how to find the integral of the type, suppose if I tell I1 that is equal to integral, suppose px plus q into dx by ax square plus bx plus c. So then this px plus q, that should be written as some a into d by dx of ax square plus bx plus c plus some b. Means we have to write it in the form b a into 2ax plus b plus b. So by comparing the coefficients, we can find a and b, and then we can integrate it. Means so if px plus q can be expressed in this form, then we can write it as a into 2ax plus b into dx by ax square plus bx plus c plus b into integral dx by ax square plus bx plus c. So this will be equal to This will be equal to a into so if we take this as t, then this will be dt. So this will be a into integral dt by t, plus this will be b into integral dx by, then this will again come in the usual form, which can come as t square plus minus k square. Then we can integrate it, and this integral will be a into log mod t. uh, yeah, we can take it as t dash, suppose, since here already t has been used, means this is dt actually. Okay, so then so a log mod t dash plus b into, so it can come as tan inverse also, or we can use that log formula also, which which we have shown. Okay, which is dt by square integral t square plus minus k square. Okay, so then so this will be a log mod t, where t dash, sorry, t dash can be is taken as a square plus bx plus c, then plus b into, this can be, this can be 1 by k tan inverse t by k plus t by k if it is plus, or it can come like mm, log, means 1 by 2 k log mod t minus k by t plus k plus c. Okay, so like this also we can write, means it can it will come this if it is t square minus k square, and if it is t square plus k square, then it will come this actually. So then suppose if you are asked to find the integral of the form like px plus q into dx by square root of ax square plus bx plus c, in this form it is. So then here also, this px plus q, that should be written in the form a into d by dx of ax square plus bx plus c, then plus b. Okay, so then this will be a into 2ax plus b plus b. So then okay, so then this will be equal to, this can be then written as a into 2ax plus b dx by square root of ax square plus bx plus c, then plus b into integral dx by square root of ax square plus bx plus c. So then this, if you take it as t, this will be dt. So this will be a integral, suppose if you take it as u, then this will be du. So this will be du, integral du by root u. Then plus it will be b into, this will be integral dx, means it will be dt by square root of t square plus minus k square. In this form we can write. So then this will be equal to a by root u, so it will be u power minus half plus 1 by minus half plus 1, so it will be 2a into root u, and this root u, that will be equal to ax square plus bx plus c. Then then it will be plus b into log mod t plus square root of t square plus minus k square plus c. So this will be the answer actually, and then t and k we can substitute here. And if it is coming in the form square root of k square minus t square, then we should write sine inverse t by k. Instead of this, we should write sine inverse t by k. So we can understand these concepts by using some solved examples, which we will take up in the subsequent videos. Thank you.